Hello and welcome to chapter 19, in which we are at present discussing various statistical tests for hypothesis testing, and in which we have discussed single t-test, then independent sample or two sample t-test, then paired t-test, then chi-square test, then one more ANOVA, in which also one-way ANOVA and two-way ANOVA. Now here we want to discuss the last important test, that is the Z test. What is Z test? So let us just do some little bit theory. Z test is a statistical test which is used to determine whether there is a significant difference between the sample mean and population mean, or between two independent sample means. Okay. Now what is the meaning? So I have shown this diagram many times. It has become a little bit dirtier, but we know that the entire business of statistical testing, and particularly inferential statistic, is this. This is the data set of say 2 million customers of my Walmart, and I want to make some particular assumption about those entire population. Now obviously I cannot do the statistical testing for that 2 million customers, so I take multiple different samples like this, right? So I take different areas, and from each area I select data points by this red colored, so that each of these blue, yellow, etc. samples, they are selected such that they are appropriately representative, and they are consisting of independent data points which are not affecting each other, like this, right? So this is suppose one such red sample which is created, and instead of just 2 million customers data, now this is just 5,000 customers data, or maybe even less, 100 customers data, right? And what we do is we find this parameter x bar, that is the sample mean, and from sample mean we try to do some statistical test so that we can convincingly say, or say with appropriate confidence, that my population mean will also be almost close to the sample mean with a certain level of confidence, right? Now that is what whole business of inferential statistic is, that study some parameter. Now it may not be mean, but it may be median, or it may be standard deviation or other parameter, but study some parameter for the sample and try to estimate the same parameter for the population with sufficiently high band of accuracy. For example, 95% confidence interval if you say, then as I said, this would be 45.65 plus or minus suppose 0.35. Suppose that is the range, and the person who has done this statistical testing, he says that I am 95% confident that the population mean would be, this is the sample mean 45.65 days plus or minus 0.35, or that means if I do that plus or minus, then I get this range 45.30, that is when this minus 0.35 is done, and 45.65 plus 0.35, so that will be 46. So I can say that my population mean is between 45.30 and 46 with 95% of the confidence interval, right? So the question is, how can I say with that certainty, for which I have to do some statistical test, and one of the statistical tests which is done to decide if my sample mean is sufficiently accurately representing the population mean or not, that is called Z test. Okay, now you read this statement and it becomes very easy to understand that the Z test is statistical test used to determine whether there is significant difference between the sample mean and population mean, or it may not be mean but sample standard deviation and population standard deviation, or whatever, right, other parameter, or between two independent sample means. So sometimes instead of sample and population you may ask to compare the mean of these and these samples. Okay, so at that time also the question is, are these two means more or less equal, or are they significantly different? And the null hypothesis will always say that they are equal, and the alternative hypothesis will say that they are different, right? But Z test is used for that. However, there is some problem or some condition which must be obeyed. One is that data must be normally distributed. Second, sample size should be much larger than larger than 30, or if it is not larger than 30, that is suppose you have taken a sample of only 10 members, 10 data points, but population standard deviation is known, then you can use that. And third is that for two sample test, if you want to compare between population and sample, that is a different thing. But if you want to compare one sample with another sample, that is two sample Z test, right? So for two sample Z test, the samples which you select must be independent of each other, right? Now let us take one practical example. A company runs email campaign. Now normally no large company runs its email campaign itself. It assigns some advertising or marketing agency. So suppose a company has assigned, a big company has assigned the email campaign responsibility to this company, a company which runs email campaign, and then it claims that the click-through rate CTR is 6%. So that means that out of every 100 emails which are randomly sent to different people, 6 emails are clicked. Okay, that is what that advertising agency claims. That means it claims that we are not sending your emails to random and useless email IDs. We are sending your emails to those email IDs from which there is a chance of some conversion. Conversion means there is a chance that some persons out of 100, 6 persons will open the email, click at various places, and they may purchase your product or service, right? Now, you are suppose the owner of the company who has given the contract to this company. So you want to test whether the observed sample rate for a sample of emails significantly differs from the claimed sample rate or not. So you will not give the big contract, multi-year contract to that marketing company directly. You will say that, okay, fine, you do your email marketing for maybe 1,000 customers and provide some email tracking facility. There are nowadays, it is possible to put that feature in the email so that as soon as the email is clicked or opened, the sender of the email knows that the email was opened. And even it is possible to do that at how many places, because in the email there might be some images of your different products or different services. So it is possible to know how many times the person has clicked on your emails in body, inside its content is there, which is called emails body. So how many times and where he has clicked, right? Now you want to test whether the observed click-through rate from a sample of emails significantly differs from claimed click-through rate. So if company advertising marketing company claims that out of every 100 emails, according to our designed marketing campaign, if you send every 100 emails, then out of every 100, 6 will be opened, and in 6 you will get significant clicks, or that means some nice conversion also you can expect. So you ask the company that you send 1,000 emails and collect the data of how many times the clicks are occurring and everything. And if your claim is correct, then in that case, out of 106, out of 1,000, maybe 60 should be click-through rate, maybe higher than that or lower than that. But is it higher or lower by acceptable limit? So what is hypothesis? That the true or observed click-through rate is equal to the claimed click-through rate by company. Observed is when you try using that sample. So you test using one small sample, and null hypothesis says that yes, company has not done anything, any manipulation with its data, and it is actually what the company has claimed. That kind of situation is there. However, so null hypothesis always means everything is fine. No manipulation has been done. Company is not lying anything, right? Marketing company is not lying. But alternative hypothesis says that no, the true or observed click-through rate when I test using a sample of 1,000 email is actually not equal to the 0.06. And for that I am using two-tailed test. Now, what is this two-tailed test and how appropriate it is to use a two-tailed test, that we will discuss later on. But I am using this two-tailed Z test. Okay. So that means suppose my company is very choosy, that if your marketing company is claiming that out of 100, 6 emails are clicked, then I don't want it to be much less. That is fine, because if out of 100 actually when you test you get only 4 emails are clicked, that is a significant difference. So then you will say that true and observed CTR are very much different, and that means null hypothesis is wrong, right? And that means alternative hypothesis is right, that true and observed CTR are not equal. But that is when it is less. But some companies are very choosy that it should not be too high also. Now it looks slightly odd to the business logic, because if the out of 100 instead of 6, suppose 9 or 10 click occur on the email, what is the harm? Because that means more users are getting engaged. So actually that is a true business logic. More users are getting engaged, and therefore higher levels are actually not that harmful, right? But still some companies want that no, I don't want higher levels also. If you are claiming that 6 emails are clicked out of every 100, then it should not be 8. Okay, why? I will tell you later on. We will do the discussion later on. So that means I don't want value on the lower side also, and I don't want value on the higher side also. Okay, so that thing is called two-tailed test. Now this email campaign is not a very fit case for two-tailed case, but there are certain cases like for example medicine manufacturing, right? Now suppose you are a big pharmaceutical company, and you have given a subcontract to make one tablet of antibiotic and to another company, and the another company claims that there is 500 milligram of antibiotic dosage in each tablet, right? Now there is one issue here. If it is less than 500 milligram, say it is less than 490 milligram, suppose, or up to a certain limit, right? Then your antibiotic will not be effective, because these antibiotics are designed after a lot of research that what is the minimal dosage, critical dosage required for effect to come. So if it is say 499 milligram, that is acceptable, but less than 490 milligram, that is not acceptable. But there is other problem also. If it is greater than say 520 milligram, then that is also an issue, because that might lead to overdose and toxicity. Okay, and in medicine that can be even life threatening also. So if you are medical manufacturer and you are giving the subcontract to some other company to manufacture under your brand name, then you will not allow lesser value also, and you will not allow higher value also. You will say that no, if you are saying that 500 milligram, then it should be between say 498 to 502 milligrams. I will not tolerate more than this variation, right? So there actually two-tailed test is required, because lesser value is also not acceptable and higher value is also not acceptable, correct? But and both can lead to serious consequences. In the email marketing, it is a subjective choice of the company. If the company decides that I want both sides unacceptable, so if 6 is there, then from 6, 7% is acceptable, or maybe 8% is acceptable, but much less rate or much higher rate are not acceptable. That is what your company has told to this marketing company. So now you are testing it, and therefore you are using two-tailed test. Steps are usual initially. At least we are creating the data. So import NumPy, import matplotlib, these are common. This is just one thing. From scipy.states, import norm. Now for z-test, there is no direct importing of test itself. Just like for t-test, we just write import t-test underscore 1 or something, then t-test underscore ind for two sample independent tests. Here we cannot import z-test directly. So we have to go by definition of z-score. So that's why, but for that definition of z-score, you will require this norm. That is why we are importing this norm library. Simulate the data. So sample size is suppose 150, and true click-through rate, that is what is claimed click-through rate, or that is what the population click-through rate should be, okay, according to the company's marketing company's claims, is 0.06, right? Now you are observing the clicks, so you are testing it by sending a sample, and this time you are sending a sample of 150 emails, and you are deliberately I am deliberately generating a data whose click-through rate is 7. Okay, so 7 is as such within acceptable limit, but let us see. I am saying 7 is acceptable because 6 and 7 are not far different. That is not the way things are done in data science, right? You have to find the significant difference, and you have to check whether this hypothesis is obeyed or this hypothesis is obeyed. Okay, so here I am doing this, and I am getting observed click-through rate is 0.06. It is the mean of those 150 observations. So if I still print one more, then it will become even more clear. Print and observed clicks. So that will print all the 150 observations. That sometimes you get the click, yes, email was opened, 0. Sometimes email was not opened, 1, and so on over this 150 emails which you bombarded on 150 prospective clients, right? And you took the mean of that, and you found that the mean is 6.66% or 0.066. Okay. Now you don't need to worry from where this data will come. Here I am synthetically generating, but they might say that this data will actually be done by doing an experiment, that you send the 150 emails and check how many emails were opened. Because as I said, some trackers are nowadays possible with that it can track whether email was opened or not. Okay. Now the question is that company used to claim that 0.06 or 6%. I am getting 0.666. So claimed is what is for population, and observed, that is what is for sample. So that means this is for sample, X bar is 0.0666, and for population I am trying to become confident that if this is 0.666, then I am confident that this population mean also will be same as the claimed, that was 6%, right? So then now I am testing my hypothesis that the true or observed click-through rate, that is this, is equal to claimed click-through rate or population click-through rate which the marketing company claimed, right? First, understand the setup of hypothesis testing, that is important. Now the question is how to do this Z-test, because as I said, there is no directly import Z-test in SciPy library. So you have to go by definition. Then this is the definition of Z-score, that Z is equal to X minus mu, X bar minus mu divided by sigma, where Z is the Z-score which you are calculating, X bar is the value which is being evaluated. So that is the population population click-through rate, because, or you are just finding that how much away your observed, mu is the value mean of this observed data points. So that is the sample mean, right? And while X bar is the population mean, and you are just finding are they two sufficiently close enough so that I can say that observed and claimed means population, observed means sample, they are equal, or are they far away from each other? X bar and mu are far away from each other, right? And sigma is the standard deviation. Okay, so I am given population click-through rate is 6%. That is what my marketing company claimed. So I am printing that, and population standard deviation I can easily find from click-through rate. This is population mean, right? So population square root of population click-through rate multiplied by 1 minus population click-through rate divided by sample size. Standard error for proportion. Okay. So that's why normal distribution is important, because these assumptions, these equations, that population standard deviation is this much, that does not hold true for all data distributions, right? So you will print that what is population standard deviation, and then you will calculate Z statistic using this, that X bar, this is my X bar, this is mu. So mu is population click through, sorry, here it is in reverse order, but that is okay. I can change the order, because you will see that it does not make any difference. X bar minus mu, okay, observed click through rate is mu, and divided by population standard deviation. So p value I can find, and if it is two test, yeah, what is p value? Then it is given by this formula, 1 minus norm dot CDF cumulative df, okay, absolute value of Z statistic. And since we are taking absolute value, therefore I said here that whether you write observed minus population or population minus observed, it does not make any difference while calculating Z statistic, because you are taking it in modulus. Okay, you are taking a positive difference only. So absolute value, and this is the equation by which the p value is calculated by definition, right? And therefore we imported this norm here. So that norm is used here, 1 minus norm CDF. And why we are multiplying by 2? Because it is two-tailed test. I have told the marketing company that if you are claiming that 6 out of 100 emails will open, that I don't want 7 is fine on the higher side and 5 is fine on the lower side, but I don't want much higher values also and much lower values also. So that is why I am doing two-tailed Z test, and therefore here I am multiplying by 2 for the p value, right? And whatever p value comes, that I will print here, and then thereafter it is the same thing, that if p is less than alpha, then in that case I will reject the null hypothesis. My null hypothesis says that true and observed click-through rate are equal, or that means whatever the marketing company is claimed, that is correct, and there is no anomaly in its claim. So normally, all normal, everything well and good, that is always null hypothesis. But if by chance p value comes out to be greater than alpha, 0.05, then in that case I will say that I fail to reject the null hypothesis, or that means I cannot reject this. I have to if p is greater than alpha, then in that case I fail to it. So if p is less than alpha, then reject the null hypothesis. So if p is less than alpha, then you will say that this is wrong. True and observed click-through rate are not equal. And in that case, you will say that if p is less than alpha, then the marketing company is claiming false thing, or that means this is rejected, means null hypothesis says there is no anomaly in the claim of the marketing company, but it is rejected. So that means there is anomaly, and true and observed click-through rates are not the same, right? So if you actually do it, let us calculate now. So this is the code, and it gives you this result, that 0.06, that is what population click-through rate. That was the claimed click-through rate. The marketing company said that 6% of the emails will be converted. Then population standard deviation, which I calculated using this formula, because I am assuming that normal distribution is obeyed. Okay, so that is 0.01939. Fine. Z test result. So that is output of this. Observed click-through rate. This was population, but when I did the sample of 150 emails, and I got this kind of result for the click-through data. So observed click-through rate was this. Okay, so observed click-through rate is 0.0667, right? And now print Z statistic. How Z statistic is calculated? That is actually population click-through rate, this minus observed click-through rate, that is this divided by standard deviation. Okay, and of course while doing that, you can while finding the p value, you can take absolute value of Z statistic. So if you find Z statistic, it is coming out to be minus 0.3438. As such, also in Z statistic, if it is a two-tailed, then plus or minus does not matter. So that means you can say that its value is important, 0.3438. Okay, that is the value of Z statistic. And the p value, if I calculate using this equation, 1 minus norm dot CDF, absolute value of Z statistic, then that comes out to be this much. But that is for two-tailed, and therefore I have multiplied by 2. So that is 0.7310. But whatever the value, that p value is far, far greater than this. So that means this is not obeyed, and that means I will not enter this part, that reject the null hypothesis. No, my p value is much greater than 0.05. So these will be obeyed. What that says, that I fail to reject the null hypothesis, and that means there is indeed no significant difference between observed and claimed click-through rate. I fail to reject null hypothesis means null hypothesis is obeyed. So which says that yes, companies claim click-through rate and my observed click-through rate, they are equal within the limits of statistical significance, right? So I will pass that company's tender, and I will assign that company the marketing contract for next maybe 4 quarters, thinking that it seems to be a marketing company with some integrity, right? Okay, let us plot something. Yeah, here there is some other thing also, that what is this Z score. Before I plot it, I will require that is why. So Z score for 95% of the confidence interval, that is 1.96. That you remember earlier we had used, because I told you that there is no need of remembering entire Z table. In fact, nobody remembers it. Z table will be given to you, or you can look it up using internet. But at least these few important confidence intervals and corresponding Z score you should remember. So among that 95% is corresponding to Z is equal to 1.96. That is one thing. And second thing is, that gives idea about that from where that alpha significance level 0.05 is coming. Because much earlier when we started this hypothesis testing, I said that alpha is equal to 0.05. We are just taking as one what you call a standard value for all our entire discussion. That does not mean, I use this word, that does not mean that alpha is always 0.05. It can be different, but I don't want to add the complication, so we will use this as standard value, right? Now that is because that 95% of the confidence interval, so that is 95 is what? 0.95, and 100 is what? 1. So 1 minus 0.95 if you do, then what will you get? 0.05. So that is the same thing as that alpha is 0.05, right? So one person says, I am satisfied with my hypothesis test with 95% of the confidence interval. My observed click-through rate and the population or the claimed click-through rate, they two are matching. Another person says that my significance level is 0.05 and the observed and the claimed click-through rate are equal. Then both are talking the same thing, 95% confidence. So 1 minus 0.05, or that is 0.05 is the significance level. But you should understand that that is not a rule. Suppose there is that critical example of medicine and overdose, right? So in medical science, if you are working in pharmaceutical domain, then sometimes 99% confidence interval is required, right? Because in that case, you are playing with life of someone. So we want to be very, very sure. And in that case, what will be the value of alpha? Then 0.01, right? So there this will be 0.01. But for majority of other application, apart from healthcare or maybe control of nuclear reactor or that kind of applications where the repercussions are very, very serious, 95% confidence interval is considered good enough. Okay. Now let us visualize this. Okay. And in visualization, now this all part are fine. I will first plot the graph and then I will explain what each line of code is doing. Okay. So for that, I should minimize slightly. A little bit apologies for small size, but for example, this line, x is equal to np dot linspace minus 4 plus 4 and 1000. So that is this minus 4 plus 4, and between minus 4 and plus 4, there are 1000 points. That is what it says. Y is equal to norm.pdf x. So this y is equal to normal distribution, okay, normal probability distribution of these values, minus 4 to plus 4, and that gives a bell curve or Gaussian curve. Right, then plt.figure fixed size, that is easy. Plt.plot, that is also fine. X versus Y plot we are plotting. So this is itself this blue colored, that is itself X versus Y plot. plt.xv line, V means vertical line, at the Z statistic, and color is equal to red. So my Z statistic of this whole thing, let me again magnify so that you can see, was 0.3438, right? So as I say, value is important, sign is not important. So here, this is 0.3438 on the positive side. I want to draw one vertical line, and this is 0.3438 on the negative side. So I just draw one boundary that if I am within this region, then in that case, I would say that Z is less than 0.3438. But Z is less than 0.3438. That is just another way of saying that alpha is less than 0.05, or that is just another way of saying the same thing, right? So alpha is less than that. That means that p value is less than alpha, and that means reject the null hypothesis for this region, right? But on the right side and this side, everywhere there is nothing for that. Sorry, here reject the null hypothesis will not become, but here this will become the range of negative z to positive z. How does that matter? That we'll see, right? Now let us plot. So this is that vertical line drawn by red color. Another vertical line at minus z statistic. So one at plus z statistic, this, and another at minus z statistic. So that is this. Okay. Now then feel between. Now this is important step. X 0. So you feel between x comma 0 y, where x is less than minus 1.96 or x is greater than 1.96. But on x-axis you are plotting what? You are plotting z score. So that means this is z score less than minus 1.96 and z score greater than 1.96. Does this 1.96 remind you something? Yes, it is the 95% confidence interval. So plot the region where it is less than 95% confidence interval. So this is somewhere 1.96 line, this vertical line here, okay, minus, and this is plus 1.96 line, extremely close to 2, right? Then this is saying that if x is less than this much, then fill the region with red color, and if x is greater than this much, then also fill it with red color. Why? That we are telling. But and some transparency is selected by alpha is equal to this, and label that as rejection region. So that means if my this vertical line would fall here somewhere here, then I would say that null hypothesis is rejected. Or my vertical line would fall here on this side, then I would say that null hypothesis is rejected. But my two vertical lines corresponding to my z score, this 0.3438, they came out to be where? They came out to be far away from rejection region. So that means that I am confident that I am not venturing into the area where null hypothesis is rejectable. And what is null hypothesis saying? That so I am not venturing into the area where null hypothesis is rejectable means my p is not less than alpha. Otherwise, I would venture into this area, right? But my plot says that I am always within this area. I fail to reject null hypothesis because this area between the two negative and positive z-score is where my results lie, and that my statistical results lie. And that means I am never entering into the rejection area. So it is clear that this part of the else statement will be executed. So fail to reject the null hypothesis, or there is no significant difference between observed and claimed click-through rate. But suppose these values have been such that this z came out to be 1.99, okay, or minus 1.99. Now where will be that 1.99? Here. So this red colored line would be here, 1.99. So then it would be on the right side of 1.96, or here minus 1.99, or why only 1.99? Maybe 2.99. So it will be far away, and the line would be somewhere, or 2.5 z. So 2.5 z would be here, vertical line red, and this vertical line would be minus 2.5 z here. But then that would be alpha less than alpha less than p value, or p value greater than alpha, right? So in that case, I fail to reject the null hypothesis, and therefore, then p value will be less than alpha, and I will reject the null hypothesis. But that is why this region is called rejection region. This is the region in which you can reject the null hypothesis. But here I am, my z-score leads me to this region. So that means I am far away from rejection region. So I cannot reject the null hypothesis. Okay. Rest of the things are very easy. Comparison of this other plot is just a bar chart of comparison of click-through rate. So this was my claimed click-through rate, and this was my observed click-through rate. And I can see clearly that there is hardly any difference. The marketing company claimed that 6 out of every 100 emails will be clicked upon, and I found that 6.6 on an average are clicked upon. So it is okay, fine. That much difference is not statistically significant enough to reject my null hypothesis. So I have to accept my null hypothesis, and therefore true and observed click-through rates are equal. Okay, that is the meaning of that null hypothesis. Now this is the explanation of code, so that is fine. This is the explanation of visualization, that is also fine. Now that one part which I want to discuss is this part, right? That what is the recommendation in this case? Observed click-through rate aligns with the claimed click-through rate. So you can focus on other marketing metrics also for more evaluation. At least you can see that company is correct as far as click-through rate is concerned. But sometimes it is possible that the prospective customers are just clicking on the emails, but that is not being converted into purchase. Okay, so you can focus on other parameters like actual conversion or opening rate, or maybe what is that means cost of opening your email, because ultimately you are paying something to that marketing company, So out of every 100, 6 emails are open, but the company will charge for 100 emails. That is how marketing companies make a lot of money, right? So company will charge for 100 emails. So then what is your opening rate? Then what is cost for one click, etc. parameters also you can check. And then if you find then it is aligning with your business goals, then you give the contract to that marketing company. But as far as CTR is concerned, at least the claim of the company seems to be correct. Now there is one issue. I said that actually this is not the case like that criticality of medical dosage where lower and higher both values should have been neglected. Ideally, most of the businesses will prefer that only. That if you are claiming that 6% is your click-through rate, then actual click-through rate when I test using my sample should not be less than 6. If it is more than 6, I don't care, because more people are opening my marketing emails, and therefore there is a greater engagement. So even if it is 15 or 20, I don't care. That is what majority of the company will think. Or that means if you undershoot your claims, then that is a problem. But if you overshoot your claim, then that is not a business problem. So in that type of case, instead of 2-tailed test, you will just do 1-tailed test. Okay. And that is simple. Only 1 or 2 lines of code needs to be changed. For example, here the p-value was multiplied by 2, and you got this p-value 0.7310. But now I am taking 1-tailed test. So these 2 will be replaced by 1, and at that time this multiplication by 2 will be removed. That is one change in the code, and another change in the code will be somewhere here where the gap is filled. then lower side will be still rejection region, because if Z is lower, that means that your click-through rate is less than the claimed click-through rate of 6%. But on the higher side, now there is no rejection. If Z is even much higher, no problem, 2.5 or 2, no problem, because that means that 12 emails are getting opened out of every 100. So fine, company has no issue with that. Your company has no issue with that. So you will tell the marketing company that I don't have any issue with that, right? So then in that case, what will happen is this thing will be removed, and the shading should be only, rejection region should be only on negative side. Let me plot this, and let us obtain the result. First, that p-value for two-way Z, two-tailed, not two-way, sorry, two-tailed Z test, p was 0.73. Now it is coming out to be 0.36, half of that, because that 2 in the multiplication has been removed, right? And here, if I plot the graph also, then now you can see there is only one rejection region. My Z is here. So that means that I am on the right side of the rejection region, or I am not in the region where I can reject the null hypothesis. So still, the ultimate result did not change, because this p-value is still higher than 0.05, or that means that this part will be executed. I will fail to reject the null hypothesis. Null hypothesis and alternative hypothesis itself will change, however, if I do one-way test then. So then what will be the null hypothesis? Then it will be this. Observed click-through rate is less than or equal to claimed click-through rate. That is my null hypothesis. But alternative hypothesis is observed click-through rate is greater than the claimed click-through rate. But I get this p-value is 0.36 or something here. This, right? 0.36 or something. So in that case, I am getting that p is greater than alpha, and that means that null hypothesis will not be able to, you will not be able to reject. So even for one tail test, null hypothesis is still valid, that the observed click-through rate is less than or equal to the claimed value, right? So that means you are not entering into this one-sided rejection region. And for all these values of Z score, the observed click-through rate is less than or equal to claimed value. Okay, so that is fine. But you may find that why this confusion about two-way and one-way, two-tailed and one-tailed Z test. So that is because I told you about that medical tablet manufacturing, where high dose is also dangerous because it might lead to toxicity, and low dose is also dangerous because it might not create the desired effect at all, right? So in that type of case, you will want to do two-tailed. But in email marketing, it is your choice. You want to do one-tailed or two-tailed Z test. Okay, now let me make this once again what it was, correct? So that in my next run, I can first plot the correct graph for two-tailed only. So I had made two changes, which I again corrected, and now again my p is this, so two-tailed Z test, and again both sides will have rejection region. Bitwise OR is not supported, but it was there. What is the problem? I think yeah, here I think this was put in a parenthesis, perhaps. Most probably. Let me make it like earlier by, okay. So I think it was correct only. This would give Z 0.73, and this would plot two rejection regions, right? Fine. So it is now like old. Now here I have done some discussion about when to use one way or higher click-through rate is why preferred. Because higher means that you don't care about this rejection region. Your rejection region is only one. If more than 6 emails are opened or clicked, then fine, you don't care. You don't care. In fact, you will perhaps reward your marketing company more. Why? Because more emails are opened than what the marketing company claimed means higher engagement. That your prospective clients are engaging with your email. More return on investment, because you are paying for 100 emails, right? So for 100 emails, if you are paying 100 rupees, so then your return on investment is only 6%. But instead of that, if 12 emails are getting opened, then your return on investment will be 12%, and that is better, double return on investment. Then more conversion opportunity, because out of 100 emails, marketing emails, 6 are opened. Then how many of them will are likely to convert into a paying client? So maybe out of 6 only 1, but out of 12, then that will be 2, right? Out of 80, then on an average that would be 3, like that. So more conversion opportunity, and therefore higher click-through rate is considered more relevant. However, there are some exceptions also. Then why did I take this example with two-tailed first? Because as I said, there are certain companies who will tell you that if as a marketing company you are claiming that 6 is your click-through rate, then I don't want lower, that is fine. Less than 5.5 on an average is not acceptable. But I don't want even greater than 7 also, on higher side also. Because there are scenarios where high click-through rate is not acceptable. For example, low quality traffic. If a high click-through rate leads to irrelevant user clicking, For example, due to misleading ad copy or poor targeting. So the company whom you have assigned the job of sending emails, that same company will create an advertised copy inside the body of the email, right? And that same company will choose to whom it will blindly bombard the email, thinking that out of them, majority or many will be prospective clients. But sometimes it is possible that the company's ad copy is misleading in the sense that your product is supposed for a fixed income investment product, but the ad writes that 30% annualized return. Now that's why many people click, right? But that is a misleading ad, and as soon as the person will read the details of inside the ad and he finds that this is a fixed income product, he will immediately become angry on your company that you are trying to fool the person. Sometimes it is poor targeting. It is possible that your product is for investment, but you are targeting it to some people who are actually, your product is for debt investment or fixed income investment, but you are targeting it to all the investors, including stock market investors and everybody. So they will read that 36% annualized return and therefore they will click it. But they are not the real client whom you are targeting. Okay. So high click-through rate does not always mean quality clients are being targeted. It might adversely affect your reputation, or it might be due to poor targeting. Okay. And therefore there will be higher cost without improving conversion. Then there is cost consideration. There are certain marketing companies who will charge you pay per click. Now there is the problem that therefore they are likely to provide this kind of misleading ad copy, or they are likely to target all random kinds of people because it is a pay per click model, and therefore instead of 6, if 15 people click on it, then they will get more fees, right? But does that more higher number of clicks get translated into higher conversion or business for you? No. So in that case, you are just unnecessarily spending more money on marketing because of pay-per-click model, and still you are not getting the click-through rate, correct? Then brand impact. Sometimes the higher click-through rate just means that marketing company has provided some clickbaits. Okay, clickbaits are certain tempting links which raise some kind of curiosity or maybe greed or something in the mind of the email receiver, and he is tempted to click it, whether he is actually prospective client or not. But as soon as he clicks and thereafter he finds in the body of email that there is nothing related to that clickbait in the body of email, and it is just a bland fixed income product which the email is trying to sell, then it will actually adversely harm your brand reputation, and it will create a poor user experience. So many companies not only want less click-through rate, this lower region is rejection region, but they also don't want high click-through rate. So that means they don't want very low Z score, but they also don't want very high Z score. That means these red lines, they don't want to be here also, and they don't want to be here also. They just want that the red lines remain far away from the rejection regions on both higher and lower side, so that null hypothesis is never rejected. And null hypothesis said that observed click-through rate is the same as the company's claimed click-through rate, and it is never rejected. So that means yes, that if the marketing company claimed 6, then maybe instead of 6, 7 emails were clicked, or maybe 5.5 emails on an average were clicked. That is out of 155 emails were clicked. Out of 10, 5, out of 100, 5.5, that means out of 1,055 emails were clicked. So that is okay, but higher is also not always better, right? So therefore, we started with two-tailed click Z test. I hope that this lengthy discussion made the thing very clear, because hypothesis testing is the central limit theorem which makes hypothesis testing possible and scientific. These are the brain, heart, and soul of the data science, right? So all hypothesis tests are now testing tools we have introduced, and now the chapter will be over. So their next lecture will be perhaps the concluding lecture, I think. Yes, because here somewhere I think exercise should start, maybe somewhere where the exercise are there. Maybe I think 2 lectures will be required, 2 or 3, I don't know. Okay, so it will be pretty lengthy discussion, but still we are now 95% of the chapter is over. So you need not worry about the length, and hang on in this chapter. Thank you, and we'll meet in the next lecture.